Okay, so this is number 102 from chapter 6. It says, using the periodic table as a guide, write the condensed electron configuration and determine the number of unpaired electrons for the ground state of letter A, bromine. So first we want to find bromine on the periodic table. Bromine's right down here. And then find the noble gas that is previous to bromine. So following backwards here, the closest previous noble gas is argon. So we'll write down argon in brackets. That'll give me the condensed electron configuration core. And then we would find 4s2. So I'm going to write it like this, 4s2, and I'm going to put 2 electrons in there, showing the orbital notation. Then we go to the 3d right here, and there would be 3d10, so 5 orbitals, 1 electron in each orbital before they pair up, and then start to pair them up. So 10 electrons right there, represented by the arrows. And then there'd be 1, 2, 3, 4, 5 electrons in the 4p set of orbitals. 3 orbitals because it's a p sublevel. 1 in each orbital before they start to pair up, and then pair up 2 of them. So to answer the second part of the question then, after you've written this orbital notation, it wants to know how many unpaired electrons are there in the ground state. Well, this is the only unpaired electron there is, and by ground state they mean that all the electrons are where they're supposed to be. None are promoted to a higher energy level like it would be in, like, say, a flame test lab or something. And so in letter A there is 1 unpaired electron. All right, let's do letter B. B is gallium, Ga. So let's put gallium up here. Gallium's right here, element number 31. The noble gas preceding that would be argon. So we'd write Ar. And then it'd be 4s2. Be filled just like this. And then it'd be 3d10, just like we had right here. And then we'd have 1 here in the 4p. So in the 4p energy level, there'd be 3 sublevels. We'd have 1 electron in those sublevels. So there'd be 1 unpaired electron here again. Letter C is the element hafnium, Hf. Hafnium's right here, element number 72. The noble gas preceding it would be xenon. So we'd put xenon in brackets. Then we'd go 6s2. And so we'd fill 2 electrons in the 6s2. Then we'd have this 4f area right here. So we'd have to write 4f14. And there'd be 7 orbitals there. And that would be completely filled. So there'd be electrons in each one of those orbitals, totally full. And then we'd find hafnium right here. And so it'd be, let's see, 71 and 72. There'd be 71 right here that it would actually fill this box, and 72 that fills that box. And we'd be in the 5d set of orbitals, because this would be the 6th period or the 5th d area. There would be 5 orbitals inside of that sublevel, and there would be 1, 2 electrons in there if we count them. So 1 would go in this orbital, 1 would go in another orbital, so we would have 2 unpaired electrons there in letter C. Letter D is Sb, so antimony right here. So antimony's preceding noble gas is krypton, Kr. And then we'd go 5s2, 4d10, and then we'd go 5p, 1, 2, 3. So just writing the 5p part, we'd have 1 electron, 2 electron, 3 electrons. We'd know that all the preceding parts would be completely filled. So these would be filled, and there'd be no unpaired there, and these would be filled, so there'd be no unpaired there. But here we'd have 3, 1 in each orbital before they pair up, and so this would have 3 unpaired electrons for it in 102 letter D. Lastly, we have 102 letter E. Ooh, 2 more to go. Bismuth. So in bismuth, we are way down here. So the preceding noble gas then would be xenon right here. So you'd write xenon again. And then we'd have 6s2. We'd have the 4f14. Then we'd have the 5d10. And then we'd have the place where we'd get to unpaired. So we're in the 6p, 1, 2, 3. So the 6p orbitals, there'd be 1, 2, 3 electrons in there. So we'd have 3 unpaired electrons there in letter E. And then lastly, letter F, Sg. Well, this one's way down towards the bottom right here. Seaborgium, named after Glenn Seaborg. And then we have, let's see, radon as the nearest preceding noble gas. So Rn. And then we'd go down here and we'd have 7s2. And then we'd have the 5f14. And then we'd have the 6ds. And remember, ds have 5 orbitals. 1, 2, 3, 4, 5. And we'd be 1, 2, 3, 4 elements into that. So 4 electrons would fill in here. 1, 2, 3, 4. So we'd have 4 unpaired electrons in this element.